Okay, so we're going over the generalization part. You should have done all the graphing in your for homework and maybe try to do the generalizations, but I know they're kind of difficult. Did we finish in this class? I get my two classes mixed up. So did we finish the generalizations of the vertical
dilations?
Yeah.
Yeah.
Did we finish horizontal dilations?
No.
No, that's where we were?
Yes.
Okay. Okay, so I don't actually have my drawings up here because I wrote on that page already. So I don't actually have my sketches up here, but you should have yours in front of you. We have two issues because the question's asking me to generalize what happens to a function if I replace x with a of x. So inside the parentheses, that x value is now being replaced with a of x. I have two separate situations. In the first one, I'm multiplying by 2, and that does one thing to the functions. And in the second one, I'm multiplying by half, and that does something different. Now, here, we talked a little bit yesterday about it's almost impossible to tell in linear functions what's happening. So don't look at the linear one when you're trying to answer these. Look at quadratic, because it's a little easier to tell. So just verbally explain to me, like just in general, what happens to the image of B, of this quadratic, when I'm multiplied by 2. It squeezed it in. It looks skinnier, right? It made it narrower.
Okay, why did it do that? That's what I was talking about when I texted you, that my lines kept staying in like this.
You didn't change you had to change your F1.
I did. I remember I would go back.
Or your F2. You had to change it.
Yeah, I knew I had to change it, but I kept doing it. That's why when I was trying to text you,
You know what I bet happened. Okay, on these calculators, when you graph, there's a little check box. And if the box isn't checked, I'll show you what I mean. I think I got something.
Oh, the little box on there?
Yeah.
It was checked on my F2, but I don't ever remember looking at my F2.
It has to be checked on both or the graph will show up. That little box has to be changed. And that's so that if you wanted to leave a function in here but take it off the screen, you could go unclick it. And that way you didn't have to erase it and get rid, especially if it's a really complicated one. You can just unclick it and it won't show up. Okay, so it's supposed to get me, it looks narrower. But this is a horizontal situation. I know it's a horizontal situation because that 2 is inside the house, horizontal, it's inside the house with the x. So it's a horizontal situation. So what would be happening horizontally to make something look like that? What would be happening? That would be happening vertically, but it's happening this way? It's a compression. It's a horizontal compression. So down here, if A is greater than 1, it's a horizontal compression.
Okay, now it's working. I don't know why it wasn't working before, but now it's working.
You probably just had something flipped off or something.
Do you want me to fix that? But I didn't in on my...
It's okay. Okay, on the 3 that are at the bottom of the page, looking mostly at the quadratic because it's easiest to see, it gets a little bit wider. That's because it's a horizontal stretch. Bless you. It's as if somebody's grabbing each side and pulling it out. Now, we will talk about these horizontal stretches and compressions in this unit. This unit's all about transformations and how we change a function. And then we won't talk about horizontal stretches and compressions anymore this year. We won't use them. I might mention them from time to time, but the main reason is, real quick, everything that we deal with in Algebra 2 has arrowheads on it. If you pulled out that sheet that I gave you a couple weeks ago that had all of the parent functions, every single one of them has arrowheads. If not on both sides, at least on one. Yes? That's good. I mean, third period, I can figure something out and we can just pull this out of class. Because would that be more time? Yeah. Right. Okay, that sounds great. Yeah. Okay, thanks. Okay. Okay, so every parent function that we have has arrowheads on it, and so because of those arrowheads, you can't tell the difference between a horizontal compression and a vertical stretch. They're going to look exactly the same to you, and so we don't deal with them in Algebra 2. We'll deal with just vertical. We'll deal with vertical stretches and compressions only. We kind of shelve horizontal for a while until you get to pre-cal. We'll talk about them, but we don't really use them. So you just need to know them for this unit, and that's all. Okay. Then the next thing we did were the reflections. These you kind of know already. This top one, the reflection was on the outside. The bottom of the reflection, the negative sign was on the inside. So the way they word it is they say multiply the function rule. When they say function rule, they mean f of x. And when they say f of x, they really mean y. So if we're multiplying our y values by -1, that's a vertical change. That means it's changing this way. So we call that a reflection across the x-axis. This one will be a reflection across the y-axis.
I have a question.
Yes.
On my graph, I got it as like the parabola is the other one is like inside.
Yes, I'm glad you said that. I forgot. On this one is probably the only one you can actually see this one on. Well, the linear one's not too bad. But if you think about it, it's a reflection across. This one is a reflection across the y-axis. If you take it and you do this, it ends up being the same thing. So the absolute value and the quadratic actually look exactly the same when you reflect them that way. Okay, absolute value, these are the weird exclamations. So I kind of explained them the other day. I'm going to explain them again, especially the bottom one is just weird. The first one makes sense. If you graph the absolute value of a function, meaning it's the whole function, this one makes sense to me. All the values that are below the x-axis, all the negative numbers are flipped up. That's it. So I think that one makes perfect sense. This other one is a little bit bizarre. So remember what an absolute value does. Now, it is the distance away from 0, but what it does is turns a number positive. So with that, because of that, you can't have any negative values. So that's why I think this one makes perfect sense. Anything below the x-axis, that will be negative numbers. They have to be flipped up. They have to be positive. This is the one that's a little strange. But it's because we're making our x values positive. So think about your coordinate grid. So quadrant 1, 2, 3, 4. There's my coordinate grid. The first thing that happens is that anything in quadrant 2 and 3 would be removed. That part makes sense because that's where the x values are negative, right? So that makes sense to me that those are gone. It's this second part that's a little bit weird. points from quadrant 1 and 4. Are then reflected across the y-axis. So it's a little weird, but it's easiest, I think this one's easiest to see. Quadratic, you can't really see it because you erase it and then it flips the same thing back over there. But on the linear one, this one's kind of easy to see what's happening because this is your original linear function. Looks like this. Well, this absolute value situation says all the things in 2 and 3 are removed. So that would be those. And then the things from quadrant 1 and 4, I only have stuff in quadrant 1, it's reflected over. So that's why it did that. It made it look like an absolute value. Okay. Alright, I know those little absolute value ones are confusing. You'll get the hang of it. So here we're going to summarize the transformations. You want to punch holes in this, keep it for life.
Do you want to do that?
This transformations, we do this unit on it, and then we talk about it all year in every pair of functions, and then you come into calculus, into pre-calc, and we talk about it some more, and then you get to calculus, and I just assume you know it. So it's real important. So we're just gonna summarize everything. The first thing is x plus a inside the house. All of that is grouped together. So this is a horizontal situation because they're both in the house. Remember, with the x, everything is backwards from what you think. So x plus a is a shift left. Because anytime it's grouped with x, it operates backwards. X minus a, shift right. You'll notice on number 2, the plus a is not in the house. So it is not a horizontal issue. It's a vertical issue. So in this case, the plus a, so it does exactly what you would expect it to do, and it moves it up. And minus a would shift this down. Okay, so on number 3, before I write down what exactly is happening, you just tell me, is this a horizontal issue or a vertical issue? Horizontal because the a is in the house with x, and if it's in the house, it's a horizontal issue. So, if a is greater than 1, it's a horizontal compression. A is between 0 and 1, which means it's a fraction or a decimal less than 1. The reason we have to put this 0 here, and I'll talk about this a whole lot more, but we deal with the negatives as if it was a separate thing, because that's what causes the reflections. So we'll deal with them individually, and it'll all start to make sense in the next day or two. Okay, so now we have the A on the outside, so it's a vertical issue. This is outside. If A is greater than 1 outside, it's a vertical stretch. And if it's between 0 and 1, it's a vertical compression. is the one that I think is just a little tricky in the wording. This is inside the house with X, this negative sign. We know that negatives are reflections. It's inside with X, which means it's a horizontal reflection. So I'm going to put that first. And here's the part that I think makes this tricky. It's a horizontal reflection, so it's reflecting like this. That's across the y-axis. Because you have to think about what the mirror would be. If we were looking in the mirror and I needed it to go that way, it would have to be the y-axis. So number 6, the negative is outside the house. So it is not horizontal, it is vertical. And then here's our two weird ones, absolute value. This absolute value with it inside around the X, that's the weird one. Ones from 2 and 3 are removed. That's 1 and 4 reflected across the y-axis. The last one I think makes perfect sense. Points below are point up. So you might want to, you might want to punch holes in that, hang on to it, keep it, because you're going to need, you might need to, you're probably, at least at first, going to need to refer to it. Okay, so we're going to do some more transforming. And it wants us to transform two of our parent functions. We're going to do the absolute value parent function. They gave you some points so you can go ahead and sketch it. It's just a sketch, so it doesn't have to be perfect. Yeah, those Cindy, God bless you, I'm so sorry. I'm a horrible sketcher, but okay, we're going to use what we've just learned. We're going to use our summary sheet if we need to use it. And we're going to make predictions about what's going to happen when we apply these transformations to our parent functions. So they gave us our two parent functions so we can remember what they look like. We're also going to put them in our calculator in just a minute so we can remember. And then they're giving us a bunch of family members. See, this is why they're called parent functions. This is where it all begins. For an absolute value function, it looks like this, but it has all these children that are in the family, a bunch of different ones down here, and they have somehow altered or transformed the parent function. absolute value family. These are members of the quadratic family. We're going to see if we can figure out without looking, before we put it in our calculator, what kind of transformations are going to occur, just based on the fact that we learned what they look like. So if you'll flip the page, they'll give us our first one. They did the first one. We're going to skip that very first one. And we're going to go to the second one. So here it is. And they're doing the same transformation to both the absolute value and the quadratic. And the first thing they want us to do in this box before we do anything else is for us to predict what we think might happen. So if you're not sure, you can go to your summary page and you can look at it and find something that kind of looks like that and see if that's what you think might happen. So go ahead and make a prediction. Write your prediction down. Get your prediction written down, and we're going to go to our calculator, and we are going to put the parent functions in so that you can see what they look like and actually have the comparison on your screen. So if you have something in already, get to your graph page and delete, enter, clear everything out. For the purposes of this activity, I would like for my hash marks to be on the values instead of it auto. So I'm going to hit menu, 4 for Windows Zoom, 1 for Windows settings. And mine's still set at -10, 10, but I changed my X and Y scale. I changed my Y's also. But I changed it to count by ones, to scale by ones. Because if it's auto scaling, it's scaling in little decimals and it gives me a little bit of hash marks. I just don't want them. So you might want to do that. Then you can tab down, hit OK. I'm going to hit tab, and I'm going to put in my first parent function, which is the absolute value. Now, I didn't realize this last night that some of you didn't know where to find absolute value, and you were just typing ABS, which totally works. Your calculator's smart enough to know that. But right next to 9s, if you'll hit that button, it's called the template button. It's got all these templates you can fill in. And this one right here, mine's already highlighted because it was earlier. That's the absolute value. It's a little faster to find it that way. I'm going to hit X and then hit enter. And there's my absolute value parent function. Looks just like the one we graphed in the first page.
What did you type on there?
I typed, okay, so I hit tab. I hit the template button, which is right here next to 9. And then it pulls up the absolute value. It's like the third row. This one. Yes. Hit that and then put an X. So I put the parent function in. Now I'm going to put the quadratic parent function in. That would be x squared. And hit enter. There's your quadratic parent function. Okay, now I'm going to leave these. I'm not going to change them at all. I do want to remove these labels because they're bugging me. So okay, I'm going to delete my labels just to get them out of the way. You have to get them highlighted. The arrow will come up. I see that you say that. There it is. Never mind. I'll just move this one. It's not cooperating, so I'll just get out of it. It's annoying. Okay. Alright, so now I'm actually going to do the transformation. So I'm going to hit tab, and when it pulls up F3, I'm going to type this one. I made a prediction about what I think this is going to do, but now I'm going to check and see if my prediction is right. So I hit tab. I'm going to hit that template button next to 9 again. Absolute value, the X in. Arrow over, and put +2. So that what's in my tab bar looks exactly like this. Hit enter. And it'll put your transformed absolute value function. So the blue is my parent. That's the absolute value of X. The black is the absolute value of X plus 2. I'm going to check the quadratic and see what happens. Hit tab. I'm going to do X squared plus 2. Hit enter. It comes up in pinkish purple. It's right here. So the red was my original and the magenta is my new. So I'm going to sketch those. They have already sketched the parent functions here. That's what it did when I put it in the calculator. I'm going to check. So it looks like they shifted up 2. And I go back and I check my prediction, and that's exactly what I predicted would happen. No, leave it if you got it wrong. It's okay. That's the point, is we're supposed to be predicting what we think is going to happen. If you get it wrong, then your prediction was wrong. They predicted the weather wrong every single day. They say it's going to rain, and it never does. Okay, so let's look at the next one. Before you do anything in your calculator, I want you to make a prediction. So let's look at it and let's think through this. First, I have a negative in front. My parent functions don't have a negative in front of them like this. So that's one thing that's definitely different. And then both of them have a -2 here. So I have to account for both of those things when I make my prediction. So make a prediction, what you think is going to happen. I'm going to go back and I am not going to I don't want to delete, because I still want my 2 parent functions in there. That's so I have a comparison, so I can kind of see what happened. I'm going to just tab. I'm going to tab all the way up, so hit your up key until I get to F3. And then I'm just going to edit this to make it look like the new one. So I'm going to delete the +2. I'm going to arrow back in front of it and hit the negative sign. And then after the X, I'm going to put -2. Then I'm going to hit tab and I'm going to do the same thing for the quadratic. Arrow up and just edit what's there. So delete the +2, arrow back. This one's a little different because I have to put some parentheses. Make sure that what you have looks like what you have on your page. Hit enter. Sketch your results. So it looks like they shifted right to, yeah, and flipped over the x-axis. And then check your prediction, see how you did. Okay, they're getting more complicated. next one, before you write your prediction, just look at it. Compare it to the parent function. How is it different? Well, this one has 2 in front, so we're going to have to account for that when we talk about our true divisions. It has a -6 in the house of x, and it has a -4. So when I make my prediction, I need to consider all of those things and what they might cause. So go ahead and make a prediction. Let's get a prediction. Go ahead and check it in your calculator.
5 and 6.
Just delete, don't delete, but just go to 3 and 4 and edit them. That way it doesn't get too crowded. But you want your parent function still so you can see that. About what this one did. Look at your graph. So let's look at the absolute value. They're a little darker and easier to see. There's my original parent function. And it obviously shifted to the right 1, 2, 3, 4, 5, 6 spaces. Shifted down 1, 2, 3, 4 spaces. That's where my new vertex is. So it shifted right 6, down 4. And then it appears narrower. That 2 is a vertical stretch. Let me explain to you exactly what that means. On the parent function, you start at, it has a vertex at 0, 0. And to identify where my next 2 points are, I would go over 1, up 1. And that would get me my next point. Over 1, up 1. So over 1, up 1. So horizontal 1, up 1. This one, I draw my vertex, and in order to get my next dot, I would have to go over 1 because the horizontal didn't change. But the vertical value was multiplied by 2. So I go over 1, up 2. So this would be over 1, up 2 before I hit the graph. Which is why it looks narrower, because it has to go up twice as much. So that's why it's a vertical stretch. How are your predictions so far? You doing okay?
Yes.
Getting some, missing some? Kinda? Okay, they're getting... Yeah, this one's not more complicated, not the same. Now, this is an example of what I was talking about a little bit ago. Consider these 2 things 2 separate things. There's a negative, and there's a 2. Instead of it being a -2, don't look at it that way, because that just confuses issues. Just think of it as okay, there's a negative and there's a 2. So you think of it as 2 separate things, and that way you get the fact that there are 2 separate transformations. Make a prediction. that negative, flipped it over the x-axis. The 2 made it a vertical stretch, so it appears narrower. And the plus 1 shifted it left 1. That was a horizontal change because it was inside of x. Okay, next one. Before you write your prediction, I have a 0.5 in front. 0.5 is a number less than 1. So before you make your prediction, when you're looking at your sheet, 0.5 is a number less than 1 but greater than 0. So that kind of might help you figure out. Is that change, go ahead and answer me. Is that change a vertical change or a horizontal change? It's vertical. Very good. If you didn't hear what Cameron just said, she said if it's outside, it's vertical. Because it's not in the house, so it can't be horizontal. So this is a vertical change where your A value is less than 1. So I find that on here. That means that this is going to be a vertical compression. Now when you look at a vertical compression, think about that for a minute. That means somebody is pressing down on something vertically. What would happen to a quadratic if somebody presses down on it? It's going to get fat. So I always say fractions make them fat. But that doesn't always work because if you're looking at horizontal, but it does work for verticals. So, okay, so make your prediction, plug it in. I think the bell's going to ring in just a minute. Finish the last 2. Don't cheat yourself though. Don't just plug it in the calculator. Make a prediction. Because the whole point is learning how to see what a transformation looks like without using a calculator. So, and if you're wrong, you're wrong. It doesn't matter. That's what it's. That's why it says prediction. It doesn't say make a right answer.